In the last video, I have discussed how to prepare bar bending schedules for the footings. Now today we'll discuss about the beam, because beam is the crucial element and the main element that it transfer the load to the column. So beam reinforcement arrangement to be done as per the design and as per the requirement of the specification and the relevant codes. Now, how to do the bar bending schedule? Before that, we need to understand what is the structural drawing of beam and how to read the structural drawing of beam, that we need to understand to do the bar bending schedules. In today's video, I will discuss how to read the beam drawings and how to find out the main reinforcement, the stirrups, and arrangement of the slab and different types of beams, etc. So stay tuned until the end to get the full information about the structural reading of beam placement and the beam reinforcement. And let's jump into the subject. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload any new video, you will get immediate notifications. So let's start about beam reinforcement or then beam bar bending schedules. The first things what we need to know, that in the structural drawing we need to understand what type of beam is there and what is the beam arrangement is there. Now it is the typical drawing of a slab. Now we can show that there are different types of beam is there. What this is RB1, RB1, it is also RB1, RB1. Here it is RB3, RB4, 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 RB1, RB1. Now, here it is. There is a difference between the beam. How? This RB1 is continuous beam and there is a support here, 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 here. Now, this beam is a simply supported continuous beam. But what is the loading pattern? Is the loading pattern is, as we know, the load from the slab will come and it will transfer to the column. So here is all distribution, uniformly distributed load. But here is RB3 and this RB3. These two is spanning in between the beam. So here will be a point load and also here will be a point load. One, why we are discussing about the loading pattern? Because about due to the loading pattern, the bending moment and the shear force diagram will change, and accordingly our lap or the splicing to be also changed, because here it is a point load and it is directly coming into the main beam or the RB1. So here we cannot provide any splices because directly a uniform point load is there. Similarly, here is also point load. So these things we need to take care whenever we are preparing bar bending schedule. That's why it is very much important to understand what is the span, what type of beam is there, and what is the arrangement of the beam, which is very much crucial. That's why I'm saying that these are the primary beam, this column to column span, and these are the secondary beam that they are resting on the primary beam. Now, whenever the secondary beam is resting on the primary beam, a point load is transfer into the primary beam. So we need to consider this area is non-splices zone. We cannot provide the splices here, and accordingly we need to prepare the bar bending schedules. Now here is I will make one example only, RB1. Others you will understand in the similar way, or you can practice at your own. Now in the R1 you can see there is a column, there is a column, there is a column, there is a column. So 1 2 3 4 4 span, and it is a continuous simply supported beam. Now what we need to understand, what is the now size of the beam, that we need to understand. Now how we can get that one? From this RB1 we need to go to the beam details. Now see, here is RB1. Here you're saying type beam type 2A. So it is as per structural engineer, they can differentiate the beam type 1, type 2, type 3. It is like that. So accordingly the detail will be, the detailing will be there, and according to that detail we need to prepare the bar bending schedule. Now what to check? Width and depth. So 250 is width, 450 is depth. That means 250 in horizontal and 450 in verticals. Now elevation, that this is the elevation of the beams. TOC means, what is a TOC? That is top of concrete. So beam top of concrete will be 4.8, and the beam bottom, what will be the beam bottom? Beam bottom will be from 4.8 again is a 450. So accordingly, the beam bottom we need to understand. Why beam bottom? Because whenever we are preparing or we are doing work at the side, we need to first fix the shuttering or the formwork, and for that we need to understand what is the beam bottom. That's why we need to first calculate what is the beam bottom. From here itself we can find out the beam bottom. Now what is the reinforcement? A, B, C, D, E, F, G, then S1, S2, and then X. And now, what is this all meaning and how it will arranging in the beam, that we need to check in the beam schedule or the beam details. That is type 2A beam. Now, see, here is type 2 and type 2A beam. Now, how we can understand what is this? See, here it is mentioned A, here it is mentioned C, here it is D, here it is a D, here it is a E, and again here it is a G, and here it is a D, and see S2, S1, S1, S1. Now, one by one we will go. First is A. A, you can see there is a continuous rod or continuous reinforcement throughout the beam. So, top main bar is A. And what is B? Top extra at support. And what is C? What C? You can see the top extra at the mid span. And same way, C, F is the top extra at mid span in the second category. And accordingly, the end span also will be the A and B. So A is the main reinforcement throughout the span. B, C, and F all are the extra bar at support. So check what is that. Here A is the main reinforcement throughout the bar, 3 number 20, which means in the top there will be 3 bar, that is end to end, that is 20 dia 3 number bars. And C and F, we can see that C and F is the extra bar at the support. C is the extra bar at the end support, and F is the extra bar at the mid support. So that is also 220, and here is also 220. That means 3 number 20 bar will be throughout the column from A to B, and then extra bar will be at a B here in the mid end support, and here is also C and F, that will be the extra bar. Now, another thing we need to check whenever we are preparing the bar bending schedules. Here you see there is a bond length. It's showing bond dia. What is the bond length? Bond length at that we have to, this development length or the bond length we need to calculate whenever our beam reinforcement is entering into the column, and then what we have to provide the development or the bond length. And how we calculate the development length, that is in the IS 456. It is there, the table is also there how to calculate. And in this regard I have made a detailed video how to calculate bond length or the development length according to the IS 456. And if you are not aware, then please check the video which is available on the description box, and then you will understand what is the bond length. Now, these things we need to first check bond length. See, bond length is from the center to center, from the center of the, sorry, it is from the column span, and whenever this beam is entering into the column, from that point, that is, say for example, is a 50D is required. So from that point we need to provide 50D for the bond length. Why I'm saying bond length? Because these bond length we need to calculate whenever we are making any bar bending schedules of the beam. So this become the bond length. So bond length you have to calculate. Then there is a clear span and there is a effective span. The clear span is the span in between the column. In this clear span, what we want to know? Because this, in this clear span only will provide the shear link or the stirrups. And what is the effective span? That is the center to center distance. Now what we will understand, the bond length we have to provide it, and the main bar is 320. Here is a extra support, that is the 22 number 20. Here is also 2 number 20, and here is also 2 number 20. So this become, I understand, this become the main rod of the main reinforcement of the top. Now, what is the bottom reinforcement? See, here is a D is bottom reinforcement is throughout the bar. And here is, you can see E, and here is a G, extra at mid span. It is not in the support, which means the bending moment in the bottom is maximum in the midspan. In the same way, the bending moment at the support in the top is the maximum. Why these things need to be taken care? Because whenever we are doing the bar bending schedules, we cannot provide more than the 12 meter length of that bar. And if the beam length is beyond 12 meter, we need to splice. And where we will splice, that will be very much essential, and accordingly we want to splice the zone. See, here the bending moment is less, here is the bending moment less in the bottom, so that accordingly we need to provide the splice. So whenever we are preparing the bar bending schedule, we'll detailed calculation, we will find out how to place the bar according to the splice zone. Here itself the bending moment is maximum, that's why the extra bar is provided. So here we cannot provide the splices, so we need to splice in the support, and so accordingly in the when it is top bar, we need to splice at the midspan. Now it's become, so check what is the D and what is the E and what is the G. So D is also 3 number 20, G is E is 2 number 16. So here it become main bar 3 number 20 and E is 2 number 16. So top become 3 number 20 and 2 number 20, 2 number 20 extra, and now it is 3 number 20 and 2 number 16 is extra. So what is the extra bar length that we need to calculate? In the top you can see here is a B. This development length is all to be provided whenever it is entering into the column. Now from the face of the column is 0.25 L1. L1 is the effective length, is not the clear span. It is the effective length, that means center to center. L1 is the, sorry, it's not the clear span, the effective clear span. So here it is clear span 5.5. So 0.25 of this length, that will be the length of the main bar, extra bar plus the development length. Accordingly, this we can see 0.25 of greater of L1, L2, 0.25 of greater L1, L2. Now, from the column face, 0.25, 0.25. Here it is 6.5 and here is the 5.5. So, which will be the greater? The 0.25 of 6.5 will be the greater. So, this will be 0.25 and 6.5, 0.25 of 6.5 plus the column dimension. This column dimension also to be added. So, this plus this will be the extra bar length or the measurement. Now, what about the bottom extra bar? See, here is E. It is clearly seen 0.85 L1, which means it is not that much of difficult, because what is the clear span? That from 8 to 0.851. Here is also 0.85 L2. Here is a 0.85 L3. So accordingly, we need to cut the bar. Whenever we are preparing the bar bending schedule, we will exact length, and we will find out exact location also, and we will mark how to mark, because that is also important in the bar bending schedule, how to mark the bar, so that whenever you are placing at the site, it will be, there will be no problem, where the layman also can work. Now we can understand what is the bond length, what is the beam arrangement, span arrangement, what type of beam is there, what is the main reinforcement, what is the main top extra, what is the bottom main reinforcement, what is the bottom extra, what is the length of the top main reinforcement, what is the bottom extra length, what is the top extra length, all. Now we need to place the stirrups. Now see, here is the S1, S2, and then S1 again, S1 again. So there is a two types of stirrups is there. Now what to S1 and S2? Again, we need to check in the beam schedules. See, S1 is 8 torr at the rate of 125 center. Here is also 8 torr at the rate 200 center. That means both are 8 torr, but the only the thing is the spacing is different. Here is 125 and here is 200 center. Now what will be the S1 length? That is the X. And what is the X? Again, X is there is 1300. So from the column face 1300, or for that means 1.3 meter will be the 8 torr at the rate 150 center. And here it is also X on 1300, 8 torr at the rate 25, 150 center, and other area there will be 8 tor but 200 center. Here it is, you have to mention that you keep in mind that the stirrups, beam stirrups is always provided into the clear span only, not in the column location. It is here the beam links or the stirrups is not required. So from the clear span we need to start. So this one S1, S2 and S3. Now what is the another things we need to take care, that we need to understand what is the cover. See, here is the roof beam 30, 30, 30. That means in each side it is 30, 30, 30. That means whatever, whenever we are doing the any bar bending schedule, we need to minus the clear cover to accommodate the steel, so that the durability of the steel or durability of the concrete can be achieved. So here we will find out everything about, and here is another type of beam, type 1, A1 and 1A. And this is a typical section of beam. See, here is A, B, here is a D. And here is also typical section of a beam. And here how it is span, depth, width, all is there, and 8 tor 150 center or 1 to 200 center. So let's summarize what we need to check for whenever we are getting the beam drawing. First things we need to know beam arrangement, how the beam is arranged in a slab or in a structural drawing, so that we can understand what type of beam is there and what is the loading pattern. And according to the loading pattern, our bar bending schedule will be changed. So that our splicing zone will be adjusted, or splicing zones will be determined. Then we will go for the beam schedule, what the beam depth and beam the beam depth, beam width, beam elevation or the top of concrete, then bottom of concrete, then what type of arrangement of beam is there, reinforcement, that is top main bar, top extra bar, bottom main bar, bottom extra bar. Then what is the development length, how is the development length to be calculated, then what is the stirrups and what is the stirrup spacing, and what is the clear cover and everything. So these things we need to check whenever we are doing any type of beam bar bending schedule. So first things we need to check these all, and then we need to go for the bar bending schedule. So in the next video I will in detail I will make bar bending schedule for same beam. In the meantime, please check these beam details, and if you have any queries about how to read the beam drawing or the structural drawing, please let me know. I will get back to you, and the next video I will make it how to do the reinforcement detailing or the bar bending schedule of the same beam, so that you can easily understand how to prepare bar bending schedule of a beam. And if you have any queries regarding construction material, construction procedure, sequence, quality control and quality control procedure, please let me know. I will come with the more content like this. And if you like my video, kindly subscribe, and I'm waiting for your comments, so that everyone can be benefited from your comments. And thank you once again for watching.